Section 7.6, Solving Radical Equations containing two radicals. Our procedure is to isolate a radical term to one side of the equation, and we have two. So the easiest is to get rid of the square root of y by taking it to the other side. It's positive now. Subtracting that from each side leaves us with, on the right hand side, 4 minus the square root of y. It's positive. Taking a term to the other side changes its sign. We're now ready to raise each side to the second power with the idea of eliminating this radical. We're not going to get rid of all of our radicals in one step like we do when we have an equation with just one radical. Here, when we raise in this case, a square root to the second power, we get the radicand. On the right hand side, we have a binomial raised to the second power. If you know the shortcut, we can square the first term, square the second term, multiply the two together and double them. Otherwise, this is the equivalent of 4 minus square root of y times 4 minus square root of y, where we will use FOIL method to simplify. So we have a y minus 4. First terms multiplied together is 16. Outside would be a negative 4 times the square root of y. Inside terms would be another negative 4 times the square root of y, which makes a negative 8 times the square root of y. Last terms multiplied together, a negative times a negative is positive. Square root of y times square root of y is y. Well, we started with two radicals. We're down to one. Let's isolate it. And first things first, how about subtracting a y from each side? And while I'm at it, I'm going to subtract a 16 from each side. The y's are gone. Negative 4 minus 16, or plus a negative 16, leaves us with a negative 20. 16's are gone, equal to a negative 8 times the square root of y. We could square both sides at this point, but just to make it easier, I'm going to divide both sides by 8 so that the radical truly is by itself. The negatives cancel out. 28 has a common 4, leaving us with 5 halves is equal to the square root of y. Now ready to raise each side to the second power to eliminate this last radical. 5 halves squared, 5 halves times 5 halves is 25 fourths. A radical squared is the radicand, and I believe that's the solution, is 25 fourths. Because the principle of powers is not always true, it's always essential that you plug that solution or solutions into your original equation, and if there's a chance of ever generating a false solution, it's when you are squaring, or whatever the power is you're raising both sides to, more than once. Chances are you can generate an extraneous root at that time. So just to show the check here, it will be the square root of y, which is 25 fourths minus 4, plus the square root of y, which we found to be 25 fourths, and we're looking to see if that is equal to 4. To simplify underneath the radical, we need a common denominator. 4 has a denominator of 1, so we'll multiply top and bottom by 4. That will give us 25 fourths minus 16 fourths. Square root of 25 fourths is 5 halves. Simplifying further, 25 minus 16 is 9 fourths. Square root of 9 is 3. Square root of 4 is 2. 3 halves plus 5 halves is 8 halves, which equals, ding, 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 the 4 that we were looking for. So it does turn out that 25 fourths is our solution to this radical equation. Let's look at another one. Here we have our two radicals, and the procedure is to isolate the radical term on one side of the equation. It's already done, so we're set up and ready to go. We're going to square both sides of the equation. Squaring a radical gives us the radicand. And just like the last one, we have a binomial here times itself. So we have the square root of 2x minus 2 times the square root of 2x minus 2 minus 2, where we'll use the FOIL method to simplify this. Multiplying the first two terms together gives us the radicand of 2x minus 2. Outside we'd have a negative 2 times the radical. Inside we'd have another negative 2 times the radical. Negative 2 and negative 2 makes a negative 4 times the square root of the radical. And the last terms multiplied together, a negative times a negative is a positive, 2 times 2 is 4. So good news, we eliminated one of the two radicals with that procedure. Next, we'll want to get our terms together. I'm going to subtract a 2x from each side. 4x minus 2x leaves us with a 2x plus 3. The 2x's cancel out. We have a negative 2 plus 4. Now these are on the same side, which gives us a 2 minus 4 times the square root of our 2x minus 2. To get this last radical by itself is our next goal. So continuing to pull off common values, subtracting a 2 from each side leaves a 2x plus 1 on the left. The 2's are gone, a negative 4, square root of 2x minus 2. Now on the last one I did divide by the coefficient, and I can divide by the coefficient here, and it clearly is going to show that we have a problem on this value from the fact that we have negatives cancel out, 4's cancel out, we have a radical equal to 2x minus 2. Dividing by a 4 here, we are having a negative expression. The negative expression, dividing each of these terms by a negative, is going to result in a negative, and we cannot have a solution to an even index that gives us a negative result. This fraction, whether you do the actual division, negative 2 or 2x divided by negative 4 is a negative 2x over 4. 1 divided by negative 4 is a negative 1/4. Each of those terms is negative, or if we just floated that negative out in front, 2x plus 1 over 4, because of having the negative here in the denominator results in a negative. When you have a radical, you always will have a solution that is a non-negative solution, and that is not the case. We could take this further, but would find that none of the values work. We know right now, though, because of this result, that there is no solution to this radical equation.